Welcome to Sony Pro Live. My name is Deon LeCointe. I am the Senior Manager for Sports and IP Solutions at Sony North America's Professional Solutions of America division. This is the first in a multi-part series on IP live production. There's been a huge buzz in the market around IP and IP technology for production and broadcast environments. The hope of this series is to demystify what the IP technology is behind this huge buzz in the marketplace today. We'll be talking about the technology. We'll be talking about products that are available to help build an end-to-end IP-based production system. We'll also be talking about how the market is coalescing around a unified standard for IP for production and broadcast. And we'll also be talking about third-party solutions and applications in which IP technology is being used today and can be used in your environment for tomorrow. So sit back and relax as we go on this journey together. So let's start off with what is IP. This is the layman's definition for IP. The Internet Protocol is the method or protocol by which data is sent from one computer to another on the Internet. Each computer, known as a host on the Internet, has at least one IP address that uniquely identifies it from all other computers on the Internet. So effectively, an IP or an IP address is a unique identifier for the device connected to a network. If you look at this image here, you can see that there can be a number of devices connected on a network together. Those can be laptops, they can be mobile devices, phones, iPads, computers. They can be giant workstations, supercomputers, and servers. And the idea is that once you're connected across a network, there must be a unique identifier and a methodology in place to transmit data from a source to its destination. Maybe you're trying to download a file from a server, or you're trying to download it from a storage location on that system. There has to be a method to tell the source device, which is where the file is located, to push that file to the destination device, which can be your laptop or your mobile phone. That's where the Internet Protocol comes into play, because it identifies each device connected in the network, and it creates a methodology for those files, that content, that data, to move from the host to its destination. So how do we translate that into a production environment? So here you have an image of a production facility. And a production facility doesn't necessarily mean a production station or a post-production house. It could be a school, it can be a hospital, it could be a house of worship. It could be anything where production equipment is being used. We look at the production facility as primarily having two sides. There is the production side, or the post-production side, as some people will call it. And this has primarily been network-based. They have already been taking advantage of COTS equipment, and COTS stands for commercially off-the-shelf equipment, such as network switches, routers, and so on. They've been connecting computers that have their nonlinear editors connected, and they've been sharing files across that network for a very, very long time. And we draw the analogy to a freeway when talking about the production or post-production side of the facility, because you can have a number of users on that network simultaneously. But what happens, though, is when the network becomes congested, you will experience a slowdown. And that's why we say this is a best effort type of environment. The content that users are trying to access will get from the source to its destination on a best effort basis. It will try its best to get there. So looking at a freeway where during rush hour, you're going to run into traffic, you're going to run into congestion. The benefit here, though, is you can build a bigger freeway. You can expand the number of lanes on that freeway to accommodate the number of users within your network. And that's analogous to getting a faster network switch or building a faster network to support the amount of traffic or support the amount of users that exist on that network. However, the laws of physics cannot be defeated. Even though your slowdown may be lessened during rush hour when there are a number of users on that network at the same time, you do have the ability to push that content through. Now, if we compare this to the other side of the house, which is the live production side of the house, which has primarily been SDI based for many, many years, And SDI is something that's tried and true. We know that as long as that cable is working, the signal will get from its source to its destination. So we say that this is guaranteed signal delivery, guaranteed bit rate, constant bit rate from the source to its destination. So we draw the analogy here to a railway system or train system where on one track you have one train at one time. So on one cable you have one signal at one time going in one direction. The limitation of the SDI side, though, is expandability. When you need to expand the size of your system, you're really talking about a physical upgrade to your system. If you look at an SDI router, for example, going from HD and transitioning to UHD or 4K, you're really talking about a forklift upgrade of that SDI router, or you run the risk of having lower utilization of your SDI router going from HD to 4K. So the real goal here, the real objective with IP is to merge the benefits of both sides of the production facility. How do we get the expandability and scalability offered to us by COTS equipment like network switches with the guaranteed delivery and constant bit rate of the SDI environment for broadcast and production applications? That's where IP is taking the market. That's where we're all moving. And here are some of the benefits that you're going to get, which is what I just described. The ability to use COTS equipment, network switches that are being built by huge manufacturers like Cisco and HP and Huawei, who are building these network switches just for data centers and IT applications around the world. The ability to now utilize live production equipment in that environment. So your workflows and your operational efficiencies that you've already achieved with a live SDI environment is still maintained, but now you're able to leverage the benefits of IP, which is the scalability and the accessibility for device management and status monitoring that the IP technology really offers to you. Let's talk about some of the benefits and advantages that the IP technology is really bringing to broadcast and production environments. And we first start off with the real value proposition for customers, where you can ensure your live production is built for the future by adopting a scalable, format-agnostic COTS architecture and the network media interface, which is what I will speak to in a second. But now you have the ability to migrate from standard def and high def to UHD and 4K. You can boost the quality of your production by leveraging network equipment and existing live production hardware resources. You can maximize your return on investment by now merging your live production environment with your offline or post-production workflows. Save on the operational expenditures with remote production and resource sharing, which are just two of the applications that IP technology is enabling. And you can adapt your live production system on the fly to your production needs, which really gives you the ability to grow your environment from what you have today to what you want it to be in the future. There's also the huge benefit of using commercially off-the-shelf equipment being built by network manufacturers like Cisco and Huawei and HP and so on, as their primary goal is to build the fastest, lowest cost network switch available. So without any hindrances from the broadcast or production market, these guys are going to build the fastest equipment possible, and we can leverage that within our own broadcast and production environments. Some key points to remember: reduce capital investment by utilizing lower cost COTS equipment, greater flexibility and scalability by being able to build and grow your system to support whatever format exists in the future, better resource management by having access to every device connected to the network at one time from a single point, and benefiting from the pace of IT technology development. So what is IP Live? And you're going to hear me use the term IP Live numerous times throughout this series. And it refers to Sony's umbrella business for all of our IP-enabled equipment, the IP Live production system, and our IP Live technologies. The IP Live production system and the overarching IP Live technology effectively replaces conventional SDI environments and other efficiencies by cabling and system architecture. Using an IP live production system, all critical broadcast signals, including video, audio, metadata, synchronization, and control, are converted into packets of data and transmitted across a COTS IP network. So when you hear the term IP, specifically IP for production or live production, we're not talking about streaming. We're not talking about Skype or FaceTime or any of those other streaming formats. We're really talking about replacing your existing SDI infrastructure or augmenting it utilizing fiber cable, Ethernet cable, and COTS network switches. Those signals are converted to packets of data and transmitted across a standard network, not the public internet, but across a network that you control and you maintain. So this is very, very different from your traditional streaming technologies or streaming terminologies that you've heard of before as it relates to IP. And the ultimate goal is to create an environment that looks very similar to this one, where all of your production equipment, including cameras, production servers, production switchers, graphics, multi-viewers, are all connected through a COTS IP fabric and managed through a layer of software-defined networking, where you see there the IP Live System Manager. So this is the environment that we're transitioning to from your traditional SDI environment, where now, by virtue of the developments that have gone on with IP technology in the broadcast and production market, this is possible today. In fact, here's a diagram of a system that can already be built utilizing products and the technology that's available in the marketplace today, primarily Sony's IP technology format called the Networked Media Interface, or NMI for short. The Networked Media Interface is Sony's AV transmission interface developed to support standard definition, high definition, 4K, high frame rate, and future formats, including 8K. It is a highly scalable transmission interface containing all the functions that you would expect to find for a live production environment. So what you're gonna see down below as an example is, as we transition from traditional live production products like the BPU 4000 shown on the left with only SDI connectivity, to the right, an example of our BPU 4500, which still has that SDI connectivity, but we have augmented it with NMI connectors, which look just like SFPs that you would find on a standard network switch or other network IT equipment. The Network Media Interface has a number of components that have been put in place for use in a mission-critical broadcast and production environment. They include elements like video and audio mapping, which simply refers to the ability to wrap the live video signal and all of the accompanying information, audio, metadata, control, and so on, into packets of data that can traverse a COTS IP network. We also leverage the ability to turn on and off compression within the IP production system so that you can really take full advantage of the scalability and size of your network infrastructure. We also implement things like high availability, which is just another word for network redundancy, which we implement hitless failover, which we feel is absolutely critical for broadcast and production environments. You want to make sure that your signal is safe. Other elements include security for live production. Let's face it, we're utilizing data center level equipment for live production. We've all heard stories about denial of service attacks and other things that have gone on as it relates to data networks, and we want to make sure that we protect those live production signals. We also have device management and device discovery, network management and switch configuration, bandwidth reservation, and a RESTful API with plugin SDK ability so that we can integrate with third-party solutions that are out in the market today and who are also developing IP-based production equipment. The Network Media Interface also has a number of advantages over formats that were in the marketplace previously. If you compare NMI with SMPTE 2022-6, for example, one advantage that we have is that it's essence independent with our packetization. That means that we can put video, audio, and metadata information into any of the packets that we are transmitting from the source to the destinations. It doesn't have to follow a rigid structure as you will find in 2022-6, as the location of that information all resides within the header information of each individual packet. We also have the advantage of having frame boundary aware forward error correction, which enables clean video switching. Forward error correction, for those of you that don't know, is the ability for a stream of data to rebuild itself if information is lost as it's transmitting from the source to its destination, which is actually a regular occurrence. But by having frame boundary aware forward error correction, when you switch your video from source A to source B, we're able to do a clean switch on the very edge of that video frame. The risk you run by utilizing a technology that doesn't have frame boundary aware forward error correction is that if you switch the video in the middle of the forward error correction stream, you run the risk of creating some distortion or a glitch in your video switching from source A to source B. Here's a look at some of the technologies that are also implemented within NMI. One of the other technologies that are implemented is Precision Time Protocol, or PTP for short. This was created by IEEE in their 1588 protocol and later adopted by SMPTE and is now called SMPTE 2059. Effectively, it's creating sync across the network. It's generating a heartbeat, which you all know is critical for broadcast and production environments. Utilizing a PTP master and a PTP slave or follower, a timestamp signal is sent from the master to the follower device, and the follower then responds with its own timestamp. This goes on over a few microseconds, and there's an algorithm that creates a heartbeat or a sync signal with the assumption that the latency between the master device and the follower device is constant. So effectively creating sync and creating genlock across the network. Another technology is our hitless failover redundancy technology. And here's a comparison of how hitless failover differs from your general IT technique for redundancy. In a general IT environment, you will have a primary source, and you can create two paths, a primary path and a secondary path for your transmission as it's making its way to the destination. If a failure occurs on the primary path, a failover switch occurs to the secondary path, allowing for the transmission of data to start again. The real downfall with this general IT technique and the failover switch is that you have to wait for that secondary connection to reinitiate for data to flow again. This might be okay if you were transmitting a large file and there was a failure and then there was a secondary path because now you can restart your file transfer. But in a mission-critical broadcast environment, you will lose video and you will lose audio if you have to wait for that secondary path to come online. In a hitless failover environment, and this is implemented on all Sony IP-enabled equipment, the source is connected to the destination through two paths, two physical paths, as was in case number 1. However, we're broadcasting packets across both paths simultaneously. So in the event that there is a failure across the main path, the secondary path is always active and the received device is always listening to both paths. So even if packets of data are lost because of the failure across path number 1, the receiver device will take the packets from the secondary path and will build a complete signal without any glitches or without any distortion whatsoever. The engineering team and any administrators on the network will be notified of the failure to path number 1, but your mission-critical broadcast continues without any issues whatsoever. Another technology that we've implemented is called clean video switching. And in a traditional SDI environment, this is effectively make before break. So if you look at the case here where you have two input signals, input signal A and input signal B, and you have your network switch fabric and your receiver device. Both of those signals are being fed into the fabric, and your receiver device is communicating with the network system manager and says that it wants to switch from input signal A to input signal B. What occurs is there's an overlap between signal A and signal B. And this overlap period is minute. It's at the microsecond or millisecond level. But effectively what it means is that at that one moment on the network, you will need dual bandwidth. So if input signal A and B are 1080p, 3 gigabit per second signals, in that overlap period, you will need about 6 gigabits of bandwidth to account for that overlap. Now, this is necessary to create a clean switched AV signal on the output. Now, we have the flexibility within the IP Live production system to turn clean video switching on or clean video switching off. With clean video switching on, you may want to leverage that feature for your mission critical signals like cameras being fed into a switcher or being fed into the router. You now also have the ability to turn that feature off if you're feeding an auxiliary room or if you're feeding a remote destination where you don't need a clean switched video signal. Effectively, what the user will see on that signal will be a frame freeze until the new signal becomes available and starts transmitting to the destination. Again, this occurs at a millisecond level, but to the trained eye, it will be noticeable. Another technology that we've leveraged is compression across the network. And Sony has developed the low latency video compression technology, or LLVC for short, specifically for use within IP infrastructures. Now, some of you might be asking, why would I want to use compression in my live production environment? Well, let's take a look at maybe some of the benefits that compression does offer to you. If you look at this chart here, you can see that we have 1080i signals at 1.5 gigs, we have 1080p signals at 3 gigs, and even 12 gigabit per second 4K signals. With compression turned on utilizing LLVC, you can now get 4 channels of 1080i through a 1 gig pipe, or 2 channels of 4K through a 10 gig pipe. Now, if you look at the dynamic of 4K, for example, in today's world where you need 4 3G SDI cables to transmit one uncompressed 4K signal, with LLVC turned on across a 10 gig pipe, you're now able to transmit 2 channels of broadcast quality, visually lossless 4K through a 10 gig pipe. That same 10 gig pipe can be used to transmit 40 channels of broadcast quality 1080i video as well. So these are all just giving you more features, just giving you more flexibility in how you want to build and scale your system. You may build a 1 gig infrastructure today, or a 10 gig infrastructure, or a 40 gig, or even a 100 gig infrastructure, which allows you to support 4K, 1080p, and 1080i, and all the flavors that are in between. That's the real value of compression within your live production environment. These technologies are all open to the public and have been added to SMPTE through the registered disclosure document process. As you can see, RDD34, RDD38, and RDD40 are all disclosure documents talking to Sony's low latency video codec, the network device control protocol, and our Essence independent packetization, respectively. Sony was also involved in the ratification of SMPTE 2059, which, as I mentioned earlier, is SMPTE's implementation of IEEE 1588 for Precision Time Protocol. One of the other huge advantages that Sony has in the IP production realm as well is that we are supporting audio over IP as well, including Dante and AES67 audio over IP standards. Built into our equipment, you will have audio over IP support embedded, and you also have the ability to embed and de-embed audio utilizing Sony's multiplexer and demultiplexing NXLK IP45F option board, which I'll talk to in another video later in the series. Built into the Live System Manager, which is the software-defined networking layer of the total environment, we'll also have Dante and AES67 controls built in to truly provide an end-to-end audio and video IP-based production system. Well, that's it for now. Stay tuned for the next video in this multi-part series on Sony's IP live production offering. And if you have any questions, please feel free to leave them in the comment sections below.